Good morning, one and all. Today, we are going to see about the brake test on DC shunt motor. So, brake test means nothing but a load test. So, in the laboratory, we can't apply load practically as how the loads are connected in your home, like all the equipments are connected in your home. No, say for example, your ACs, your refrigerators, then washing machine, everything. So what are all the loads you are using? Everything is connected with you. But practically speaking, in laboratory, we can't connect all the loads. So what we are doing is we are just applying a brake. Brake means so applying some load on the shunt motor and testing the efficiency of the motor, performance of the motor. So performance nothing but to test the efficiency. So what is efficiency? Efficiency is nothing but output by input. So we are testing how the motor is running with the some load. So that also we are going to test. So here you see there are three types of motor, three types of DC motors. The first one is series motor, shunt motor, DC series motor, DC shunt motor, and DC compound motor. Series motor, it is a high torque motor. So whenever you want high torque in the sense, say for example, in some industries, they want to lift more weight. Say that one machine is there, that machine is of some 50 tons. 50 tons machine, you need to lift that particular machine. So for that, what we need is we need high torque. High torque. High torque means with the weight. With weight, it needs to lift. Okay, with weight, it needs to lift. So definitely we have to go for the DC series motor. So DC shunt motor is nothing but a constant speed motor. So constant speed is, say for example, in a thermal power station or in some industries, they want to shift, say for example, bolt nut manufacturing industry. They want to shift that bolt nut after manufacturing to that particular factory to some area like that. So between that factory to logistic kilometer or 2 kilometers, some conveyor belt has to carry that what do you call that load, that bolt nuts to that particular logistic area. So for that constant speed. So if you see some YouTube videos also, so you'll be finding that conveyor belts that carrying something. So whatever it might be, not only bolt nuts, whatever it might be in industries, sometimes they want some materials to carry from this place to that place. The distance between this place to that place will be more, somewhat more, some 1 kilometer or 2 kilometer like that. So manually you can't shift. Some workers has to go there like that. So there, wherever constant speed application is there, then we need this DC shunt motor. Next, the compound motor is the combination of both, like DC series motor and shunt motor, combination of the both. So whenever you need some torque and as well as the constant speed, so there you need the compound motor. So these two motors, like DC series motor and DC shunt motor, you'll be finding in some application in the industries. Industries, I said no, to carry the more weight, to carry more weight where the high torque is necessary. So, say for example, in olden days, in lifts also they have used this DC series motor. Why? Because in lift, how it will carry means first we'll stand. Say for example, 5 members. We are standing onto the lift. One member 70 kgs. So approximately 350 to 400 kgs or 500 kgs that lift has to carry from one floor to another floor. So there it is already loaded. So loaded and it needs to carry. That is torque. It needs high torque because it is not already we stand inside the lift, then only that lift is lifting. Okay, so with the weight that motor has to carry the thing. So if you come to DC shunt motor, that also with weight, but it carries only less weight and also the constant speed, some constant speed it will. So here we are calculating the performance of the DC shunt motor. So what is the main limitations of this DC motor in the sense supply? So first one is supply. Say, for example, in your home also, you can't use DC shunt motor. Why? Because you need to purchase a rectifier unit separately. So that's why in a domestic application, so this DC motors is not used. Okay, so 100% not at used in domestic application. Whereas in industrial application, there the DC supply is there. DC supply will be there because, as I said, for high torque they need a DC shunt motor, series motor like that. So there, the supply will be separately. They will have a rectifier unit, and from that they will convert AC into DC. So from the DC supply, they can operate the machine. So practically speaking, this can't be applicable to your how in domestical applications. Only few applications. Say for example, few applications in the sense your trimmer motor, trimmer. So that also DC motor. So what it is happening is that is like in a trimmer, that is DC supply. DC supply means you will be finding rectifier, small rectifier unit. There is some online trimmer also, and you can charge and you can use. So that is not DC motor. DC motors, some small motors. Okay, so coming to why? Because if you take your televisions also, that is also DC supply. There you'll find a small rectifier unit. So wherever you go, you just take your LED TV. The backside of there will be some charger type will be there. So there one small box will be there. That is the rectifier unit. In some TVs, they will be keeping that rectifier unit inside itself. So majority of the TVs that rectifier unit they will keep outside because rectifier unit alone, if you want to change, you need to open all the television and size of the width of the television also will increase. So that they made that rectifier unit separate. So there DC supply is there, but here this are all high end. Say for example 230 volt. There if you take your LED television, that supplies of only 24 volts, 12 volts like that. It depends on the size of the TV. Okay. And if you take your laptop chargers also, you'll be finding a small rectifier unit. Say, for example, yeah, this is that rectifier unit. So here, say, for example, with this, you can't charge your laptops. So definitely some rectifier unit will be there. So here it is 65 watts. Okay, 65 watts and input. Input is 230 volt and output is 19.5, approximately 20 volts. Okay, 20 volts and 3.33 amperes. So this is one of the rectifier. So without this, you can't charge the laptop. Okay, so without this rectifier. So like that, your LED television also same like that. You just go and see your LED TV. The same like on this rectified unit will be there. So what is the input voltage? What is the incoming and outgoing, that where the TV is operating, like that clearly mentioned. So that is of some 25, 24 volts like that. And the currents also will be vary, depends on the size of your TV, inches of your TV. Okay, 48 inches, 32 inches, like that, 65 inches, like that. It depends on the size that the power rating will be. So this is of this is not a direct DC supply. This is a rectifier unit. In our house, we are getting only AC supply, all AC supply only. There we are just converting. That's all. So that is the basics. So coming to the experiment, So here what we are doing is we are testing the performance of the DC shunt motor by using the brake test. This is the circuit diagram for brake test on DC shunt motor. So here we are giving 230 volts DC supply. Okay, 230 volt DC supply directly we are giving. So it is running by 230 volts DC supply. Okay, not AC, DC supply. So here positive and negative terminals, positive, negative terminals. After that, we are having a DPST switch, double pole, single throw, DPST switch. So after that, fuse will be there. What is the main like use of this fuse means? Say for example, any fault happens, happens in the, say for example, you are touching this light. You are touching this, automatically touching this line. So automatically what happens is this fuse will burn because if you touch automatically there will be some increase in the current because so you are touching. So automatically there will be an increase in the current, or say for example any fault happening. Fault happening means this positive and negative supply is touching somewhere else. Okay, so in that condition automatically this fuse will get blown off. Okay, so similarly you can find this kind of fuse in your fuse carrier. I think nowadays majority of the houses don't have fuse carriers because all the fuse carriers are replaced by your MCBs, miniature circuit breaker. Okay, so whatever is there, say whatever fault happens, automatically that the MCB will trip. But even though one fuse carrier will be there, say for example in one house, some 3-4 portion is there. So majorly for each like the energy meters, one fuse carriers will be there. In that fuse carrier, if you open that fuse carrier, you can find out that okay that some small wire like that it will be wounded. So that will be safeguarding your like faults. Any fault happenings, automatically that fuse will blow. That fuse rating is based on your load. Say for example, single phase means 5 amperes, 3 phase means 10 amperes, like that. If you just wound one time, it is 5 amperes. Like that, the standard fuse wire is there. If you are using some other wires, means you need to be very, very careful because so what happens is you can also use any wire, any iron wire, any wire, whichever you see, any copper wire, anything you can use. But current that rating is very, very important. If it is say for example you're winding you're wounding that fuse wire in your fuse carrier, like with any wire, instead of using standard fuse wires, what happens is any fault happens in your any, say for example any fire is happening. So due to that, automatically it need to trip and fuse has to be blown. But due to some accidents, due to say small accidents, electrical accidents, your fuse will not blow. If you are using some other copper wires, some 3-4 wires wounded together, like that, if you use, fuse will not blow. Simply like that, it will resist your current. Okay, so whatever the current is, so that much fuse amperes. Say for example, instead of 10 amperes, you are same doing 40 amperes. That any fault happens, that will not trip like a trip. Okay, simply that fuse will resist that fault. So what we need to do is this is the standard one. So you need to buy the standard fuse because standard fuse ratings you know already. So one winding means if you wound one time means 5 amperes. If you wound two times means 10 amperes. Like that, we know that standard fuse wires that you can found in some your electrical shops, electrical and hardware shops. You can found that fuse wire, small fuse wire bundle will be there. So there, if you, while asking itself, you can ask 5 amperes fuse wire, 10 amperes fuse wire, like that correctly. So say for example, suppose this fuse is also not getting. So your MCB is there, miniature circuit breaker is there, automatically it will trip. Okay, so automatically it will trip. Say for example, sometimes you may feel while you have to switch on your AC. Okay, so while switching on your AC, automatically in that panel board will be there. Automatically that MCB will trip. That inside that panel board that will be some 10 MCBs depends on your connections. 10 MCBs or 5 MCBs are room wise one a kitchen one, hall one, bedroom one, like that, and like a portico one, like that will be there. So automatically, say for example, your ACs are connected to your bedroom. So automatically, what happens is it will trip. Say for example, suddenly you're switching on your AC. So in that time, due to some transients, so automatically this MCB will switch off. So what you need to do, again, you need to switch off your AC, and again you need to on the MCB, and again you need to connect with the this. Again, you need to switch on the AC. Like that, it is there. So that is for in your house, so you're using the MCBs. So here also fuse did the same work. So to avoid any short circuit, and also if short circuit happens, automatically this fuse will blown out. Next step, that fuse is connected to this positive terminal is connected to a meter. This is all moving coil meters. There are two types of meter: moving coil and moving iron. Moving coil for DC supply, and this if you see the rating of the machine in our laboratory, it is available as 12 amperes. So for that only we are going for 0 to 20 amperes. Okay, the 12 amperes, for that we are going for 0 to 20 amperes. Next, voltmeter. Voltmeter, why we are using 0 to 300 volts in the sense. So to resist this 230 volts, because 230 volts are coming, no, so you can't use 150 volts. You can also use 600 volts, but the reading should be exact. So that's why nearby values you need to choose. So for 230 volts, nearby rating is 300 volts, 0 to 300 volts. So that's why we are using 0 to 300 volts voltmeter. Next, here you know, in the DC shunt motor, there are two types of windings. So first one is field winding, armature winding. Field winding having the rheostat of 290 ohms, 2.8 amperes, and armature winding having the rheostat rating of 100 ohms and 5 amperes. Okay, 100 ohms and 5 amperes. So here, what we are doing is this negative terminal of the ammeter is connected to this 290 ohms, 2.8 amperes rheostat. So that is connected to the your field winding of your shunt motor, field winding, that is plus Z and minus Z. So this one terminal you need to connect with the negative of the ammeter, and another terminal to this plus Z. Okay, and minus Z to this again this negative terminal. So similarly, the voltmeter has to connect it across the positive and negative supply. Okay, positive and negative terminal. So here you see voltmeter, positive terminal is there, negative terminal is there. You need to connect across. Across means, so always you remember voltmeter has to connected in the parallel, and ammeter has to connected in the series. Okay, so if you connect this thing, the changes will not happen. Changes will be very minimum, and you should not connect like that. Okay, why? Because this winding. Winding, if you just open this ammeter winding, that winding meant for only series connections. If you open this voltmeter winding, that winding meant for only parallel connection. So more windings will be there for your voltmeter, and less windings will be there for ammeter. If you connect wrongly this and this, okay, opposite. So what happens is the ammeter will go. Ammeter, first of all, ammeter will not go any like it will not the pointer will not move. So even though inside the windings will have less windings, so sometimes that windings will blown out. So again we need to replace many. We need to go for service. Many things are there. So that's why we need to be very careful while connecting this voltmeter and ammeter. Next, these motor is that is connected to brake shoe, this um, uh, like brake shoe. Okay, so there will be a brake drum will be there. That brake drum is connected to a this brake shoe, and here there are two. This is the S1 and S2 readings. Okay, so here also. So how much weight you are applying? How much, say for example, how much not weight? Yeah, yeah, how much pressure? Say for example, you are running at a 40 kilometers per speed. So what I'm doing is I'm just putting one rope on you, and I'm just catching you. Okay, so what happens is automatically your speed will decrease. Okay, speed will decrease, like instead of running 40 kilometer per hour. So what your speed will be reduced to some 30 kilometer per hour. So like that, the motor we are loading. We are loading the motor. That is speed we are loading. So say for example, same like horse riding. Horse riding, what happens? If one member sits on the horse will ride at some constant speed. Say, for example, some 60 kilometer per hour. It may run. So, say, for example, some two members are sitting on the same horse. So what happens now? The load gets increased. So the horse speed will reduce automatically. The horse speed will reduce to some 5 kilometer per hour. So 55 kilometer per hour. So similarly, like that, what we are doing is we are just applying a brake that is loading the motor, and we are seeing how the efficiency is that we are going to test. So what is the procedure means? First, you need to switch off. So this armature winding has to be in the maximum position. Okay. Then this field winding has to be in the minimum position. So after switching on the motor, so the motor might run at some 900 RPM or 1100 RPM like that. Okay, 900 to 1100 RPM. So automatically what you need to do is you need to um, uh, just to cut down this resistance. Okay, now it is with this armature with full resistance. While starting armature with full resistance, you need to cut this resistance to minimum position. Automatically, the motor might be running at some 1400 plus RPM. Next, the rating of the machine is 1500 RPM. So it may run at 1400 plus RPM approximately. After that, what you need to do is you need to vary this field rheostat. Field rheostat you need to vary. So automatically the speed of the motor will reach as the 1500 RPM. That you can see in your digital tachometer. So after that, what we need to do is this ammeter also will be having some current. Okay. So here this voltmeter also will be measuring like 230 volts. So after that, what we need to do is this brake shoe 1 and 2. So this S1 we are loading, or S2 you can load both. There is no golden rule like you need to load one like that. You can load both. So automatically you will get some load to the motor. The motor will run with a somewhat less speed. So automatically you need to load the corresponding this current and as well as the voltage. So after that, yeah, see here the observation table is there. So the load S1 minus S2. So the load S1 reading and S2 reading, that is in kilogram. Okay, so whatever the reading coming, that is in kilogram. Always remember the units are very important. So voltage we need to. So here current in amperes, actually A is missing here, a printing mistake. So speed in RPM, speed N in RPM, voltage V in volts. Here torque in nanometer. So torque in nanometer now, whatever the load. that is this one, S into R, radius of that brake drum. Okay, radius of the brake drum. How to calculate the radius of the brake drum is take your long size scale. Take your long size scale just to measure the whole this thing diameter. So after that radius you can easily calculate. Divided by 2 will give the radius. So radius in centimeters into 9.81. Sorry, radius in meters. So Newton meter, no? So you need to convert first your long size scale will be in a centimeter scale. So you can convert that into meters. Meters and you can write here. So into 9.81. So output is equal to 2 pi nt divided by 60. 2 into pi into nt speed. So 1400, say for example, 1400. Torque is some nanometer divided by 60. So input is V into I. Okay, input power V into I. Output is here also in watts. Here also in watts. This is this efficiency in the percentage. So easily you can calculate the percentage like 78 or 76 like that. Depends on the speed. So automatically your motor efficiency is somewhat around 80% of motor efficiency. There are some many losses are there in the motor. So like that you need to do the experiment and you need to calculate the efficiency. So what are the precautions? Means main power switch should be in the off position. That always should be in the off. Okay, so we'll on, and the DPST switch is in the open position. DPST switch you always remember like it should be in the open position, because sometimes by default somebody is switching on that power supply. If these DPST is closed, you'll feel very heavy shock. So why? Because this is the DC supply. So DC supply, you know, it is the constant. DC supply is the constant. It is not coming to zero. If you see the DC supply, so it will be like this. Okay, this is the time scale. So say for example, this is the voltage. Okay, it will be some constant, always constant. Okay, say for example, this is the 230 volts. Always it is a constant one. So the thing is that it is not touching the zero. It is not touching the zero. Whereas in a single phase AC supply, that is this is the DC supply. Whereas in single phase AC supply, okay, so you will get sinusoidal wavelengths. You get the sinusoidal wave like this. Okay, so sinusoidal wave, say for example, if you feel AC shocks, AC supply shocks, so this magnitude is coming to zero. Okay, after some time, after some few milliseconds, this magnitude, say for example, this whole millisecond is 20, whole time is 20 milliseconds. How 20 milliseconds? Frequency is equal to 1 by T. Okay, T is equal to 1 by F. So 1 by 50 is some 20 milliseconds will be there. The time scale of this particular the AC supply. So sometimes it is going to peak and coming to zero. So this zero time, if you are touching the wire, say for example, touching the phase wire, you can take the hand in this particular, whenever the magnitude is reaching zero, you can simply take the hand. If DC supply, you are touching, DC supply you are touching the wire, means automatically what happens is you will feel heavy shock, because it is nowhere else, it is coming to zero. Okay, so that's why in machines lab or in BW lab, we are very careful. You need to be very careful, and we are also very much worried about your safety. Always you need to wear shoes, leather shoes with thick soles. Okay, sometimes it will not grounded. If you touch any live wire also, if it is grounded, okay, via your body, if it is grounded, you'll feel like heavy shock. Okay, you'll feel the heavy shock. If That's why if you're not wearing shoes, we are not allowing you to do the experiment. Most of the times we are not allowing, because anything happens means see 230 volts AC supply, sorry, DC supply. So no, it is not coming to zero anytime. So until otherwise the MCB, if it trips off, then you'll be safe. If it's in like hard case, the MCB is also not tripping off, then you'll feel heavy shock. Okay, so you need to be very careful while say for example you're wearing the rheostat position also. You touch it wrongly that windings, there also you'll be feeling heavy shock. So these are the some of the precautions you should follow in the lab. So here, as I said, field rheostat might be in the minimum resistance. We field rheostat in the minimum resistance, as I said, and armature rheostat should be in the maximum resistant position. So avoid any loose connection. Loose connection means, say for example, say for example, this field winding, that rheostat connection is some loose connection is there. That the field winding wire is coming out. Then your DC shunt motor is it will run at a N speed. N speed means instead of 1500 RPM, it may run at 3000 RPM, double the times or more than the 3000 RPM. Triple the times it may run. 4500 RPM it may run. So, say for example, your capacity is 40, you can run up to 40 kilometer per hour. That is the world record. Okay. World record means Usain Bolt, he is the world record, no, in 100 meters. So I think it's his maximum speed is 40 kilometer per hour. I think human can run maximum up to 40 kilometer per hour because of body will not support after that RPM. Okay, so like kilometer per hour. So like say for example, what I'm doing is I'm making you to run at 100 kilometer per hour. Whether it is possible, say for example, if you're running, if you're running in 100 kilometer per hour, what happens to inside your body? Like your heart will pump like anything. Your heartbeat will increase. Then your blood flow will increase. Many things happens. I think after that you may fall also. Just after some 3-4 steps you may just fall also like that, because your body will not resist it like that. Same like that for machines also. So that maximum speed is 1500 RPM plus or minus, say for example, you can run that a motor up to some 1800 RPM like that maximum. After that, what happens is if you're running that same motor with 3000 RPM or 4500 RPM, so if any loose connections will be there. So automatically what happens is that windings inside the motor will get heated up like anything, and the life of the motor. Say for example, life of the motor may decrease. Say for example, daily you are running at 100 kilometers per hour. What happens? Automatically, the pumping capacity of the heart becomes day by day will be decreased. So automatically, sometimes your heart will arrest. So that is the same thing here in the machine also. If you are running the same machine for instead of 1500 RPM, you are running for 3000 or more than that. So what happens? The lifetime will instead of number of operating hours, say for example 1000 operating hours or 10,000 operating hours that machine is. So instead of 10,000 hours operating hours, that machine may run at only some 4,000 hours operating hours like that. So loose connections should be avoided always. So that's why we insisted in all the experiment, not only this experiment, all the experiment, loose connection should not be happens. Sometimes what happens is that loose connection happens with, sometimes that connection also will touches your meters. Meters, even though that is insulator, the hard cases, You may also touch that wire sometimes, and that some to avoid the accidents also, to avoid some accidents also. Next, the meter should be checked for zero readings before connecting them into the circuit. So always remember that meter, that pointer will be there. That should be in zero position. If not, there will be a small knob like in the bottom of that meter. So if you just vary that knob, automatically that your pointer will be vary. So you can keep that to zero, then you can start the experiment. If not, you just note down that error and you just started. So whatever the error that you minus, that you subtract from your actual read, that also possible. But always ensure that the pointer is facing the zero. That you need to ensure. Next, avoid a parallax error while noting down the readings. So avoid parallax error now. So for example, meter is there. So always you need to see in front of the, you need to stand in front of the meter. So like angle of you and your meter should be like a zero. Like you need to stand straight or, okay. So if not, say for example, if you are standing at 30-degree aside, 30-degree aside or 45-degree aside, there from there you are noting down the readings. So automatically say, for example, some 12 amperes you need to note down. That pointer is pointing out 12 amperes. If you stand 45 degrees apart and if you see the readings, instead of 12 amperes, you can see like 10 amperes or 11 amperes. Like, so 1 ampere is error. So if you just calculate your efficiency also will be less. Then you can sell like instead of 78% or 75%, your efficiency will be somewhat 60% like that. So that reading is wrong. So that's why avoid the parallax error. That is very, very important while doing the experiment. Next, only moving coil meters are to be used. MC, moving coil meters to be used. So if not, if you are using the moving ion meters, what happens is the meter pointer will not read. Some sound will come from the meter. Okay, it will load heavily. Okay, because you are giving DC supply to the AC meters means that windings will have some sound. Okay, that pointer also will not be moving. Sometimes the pointer might be moving somewhat one or two reading only, like a 0.1 or 0.2, like that. It might be reading and coming back. So there will be small variation in the that pointer. So like that also will happen. So that's why appropriate meters. You should choose the appropriate meter. DC supply means moving coil. AC supply means moving iron. So that is there. So this already I have explained. So even though procedure, give the connection as per the circuit diagram that I explained you like you might be connecting the same. Next, switch on the supply and gradually cut off the external resistance in the armature circuit. As I said, resistance you need to decrease. Automatically motor speed will pick up. So initially the like 1500 RPM machine, initially it might be running with the 900 RPM, like 900 plus RPM. Okay, so automatically if you reduce that resistance, automatically the speed will touches the some 1350 or 14,000, sorry, 1400 RPM. Approximately it will touches 1400 RPM. So again, what you need to do is adjust the motor speed to its rated value by adjusting the resistance in the armature. So armature resistance, by varying the armature resistance, you need to set that to instead of 1400, like 1400, that machine will be running. Now you can set to 1500 also. Next, even then motor is not running at the rated speed. So what you need to do is after cutting total resistance in the armature circuit, adjust the motor speeds by adjusting the field circuit. So the same thing I said, I explained already. Next, note down the no load reading of the voltmeter and ammeter. So first no load meter. So while noting down the no load meter, before that itself, by connecting the voltmeter and ammeter itself, that meter should checked for zero readings. Zero readings also should be checked, and no load readings also should be checked. Next, you need to apply the brake gradually up to the full load current in the steps. So full load current is, say for example, you need to load up to that particular RPM. Say for example, the maximum current of that particular motor is 12 amperes. So you need to vary that. You need to give the load by seeing the ammeter, by seeing the current in the ammeter. Say for example, 2 amperes you need to load the machine. Okay. Say for example, initially it's some 2.5 amperes. So again, you need to vary the spring balance. You need to set that to some 4 amperes. Next, you need to set up to 6 amperes. Like that, 2 amperes you need to set, and corresponding readings has to be noted down.